Hello all. Let us solve some problems on Hilbert transform. So find Hilbert transform of sinc function. So in time domain, sinc function is given by x of t is equal to sinc of t. So there are 4 steps here. So as mentioned earlier, Hilbert transform is analyzed in time domain as well as frequency domain. So here what we are going to do here is we are going to find Fourier transform of the time domain signal, and then we analyze the Hilbert transform in frequency domain, and then we apply inverse Fourier transform to obtain Hilbert transform. I repeat once again. So we have a time domain signal x of t. We are going to find the frequency domain component here x of f by applying Fourier transform, and then we are using frequency domain analysis of Hilbert transform in order to find x cap of f. To find x cap of t, we apply inverse Fourier transform. So in step 1, we are going to trace the signal x of t sinc t, which is given in time domain as shown, and when you apply Fourier transform on this signal, we obtain the frequency domain signal, which is in rectangular form. So x of f is nothing but rectangular function, so which is existing from minus half to half with an amplitude of 1 here. So we are able to find here two domain, time domain and frequency domain. So in the second step, we are going to consider the time domain equation and frequency domain equation for Hilbert transform. So in time domain, x cap of t is given by convolution of x of t and h of t. So that is given by in convolution integral minus infinity to infinity x of tau by pi into t minus tau d tau. So this is the equation. So if Fourier transform is available, x of t is represented in frequency domain. Therefore, this equation x cap of t is written as x cap of f, that is equal to x of f into h of f. Convolution in time domain is multiplication in frequency domain. So what is h of f here? It is nothing but the Hilbert transform of impulse function, that is minus j signum function here. So now in the next step, we are going to find x cap of f. We are now in frequency domain analysis of Hilbert transform. Therefore, x cap of f is given by minus j signum function and the function in frequency domain, x of t in frequency domain. So now, how to find x cap of f? Observe closely. Here I have in this equation minus j followed by one function signum function, and another signal is the Fourier transform of x of t. So let us trace out all these signal in order to find x cap of f. So signum function is given as follows. Signum function is defined as 1 for frequency greater than 0, 0 for frequency is equal to 0, and minus 1 for frequency less than 0. This is the amplitude of signum function for positive frequency, negative frequency and at origin. Now x of f is a rectangular function which is existing from minus half to half with an amplitude of 1. So based on that waveform, this equation we can write x of f is nothing but having amplitude 1 from minus half to half and 0 otherwise. Now what is the operation that is happening here between signum function and x of f in this equation, which is pointing? So here multiplication is happening. Therefore what we are going to do here is we are going to multiply signum and x of f. So we are going to see here amplitude here is 1, 1 into 1 is 1, and the amplitude 1 exists from 0 to half here. After half or 1 by 2 here, we are going to see x of f value is 0. So here 0 into 1 is 0, therefore no signal is present here. Similarly, minus 1 into 1 is minus 1, and the signal x cap of f exists from 0 to minus half. So based on this multiplication, we can consider this factor minus j x cap of f is given by minus j for positive frequency up to half and j for negative frequency from 0 to minus half here. Now in the step 4, already we obtained x cap of f. So in order to find the Hilbert transform of x of t, apply inverse Fourier transform. So applying inverse Fourier transform on x cap of f. So write the equation of IFT, integration minus infinity to infinity x cap of f into e to the power of j 2 pi ft into df. So apply the limit integration by observing x cap of f, which is written here from the previous slide here. So now I have written 0 to half minus j e to the power of j 2 pi ft df plus half to 0 integration level with the value of j e to the power of j 2 pi ft df. Now simplify, j get cancelled here. So apply the integration level and you will get this intermediate expression. Now simplifying, we are going to get the answer 1 by pi t minus, here we are going to see the exponential function which is represented in the form of cos pi t by using this trigonometric function. We know that e to the power of plus or minus j theta is cos theta plus or minus j theta. You add both terms, you will get 2 cos theta. So replace this expression by 2 cos pi t. So 2 get cancelled and we are going to get cos pi t by pi t. So what is the Hilbert transform of sinc function? It is 1 minus cos pi t by pi t. So this is the answer for Hilbert transform of sinc function.